So this is going to be my solution to the sliding deck door lock. I was inspired by Kaz de Buck, not sure how you say it. He posted something in the forums about his solution to the sliding deck door lock, so I was inspired by that, and this is my take on it, somewhat similar to his, but a little bit different. Components have the drop bolt lock just like he had. This is an actual wired access control keypad, fully weather rated, can go outside, doesn't need to be in a box or anything like that. Backlit, all that good stuff. A couple switches for control of the lock, and then a Raspberry Pi here to integrate with SmartThings. I'll explain that in a little bit, and then some circuitry, which eventually I will put into a smaller form factor, a smaller board, and that's just to convert levels between the keypad here, which runs on 5 volts, and the Raspberry Pi I/O, which runs at 3.3 volts, so I need to level shift that. So, and then the last thing here is this relay board, and I'll explain that in a little bit too. So, as I said, we got the locks, same one that the other guy used with the 0 second, 3 second, 6 second delay. When you apply power to it, you just use 2 wires on that. I have these 2 switches here, so they're hooked up. One of them is hooked directly up to the I/O on the Raspberry Pi, and then the other one actually physically cuts power to the lock. So in case of emergency, you can, no software really involved, you can cut power to it, get out, get the door unlocked. So these are also lit switches. Let me turn them on. So green on both of them means the system is armed and locked. So also a little bit of stuff there running through the relay board. So these are 12 volts, 12 volts, 12 volts. That's why I need the relay board. So controlled by the Pi to turn those on. This switch here toggles the state of the lock back and forth. And then, like I said, this switch just cuts power to the lock. So it's just a physical cutout on the lock. So that's what that's all about. Then over here on the keypad, I got a test code in there right now. It's just 1111. That'll unlock it. Hit 1111 again. That'll lock it up. So now, if we go over to the Raspberry Pi, so a couple things in there. One, it's controlling all the I/O to make all this happen. The other thing is I have a HTTP server running in that, and that's how I'm integrating with SmartThings. So I'm using hub actions to send HTTP commands between the hub and this Raspberry Pi to send lock commands, get the current status of the lock, those kind of things. So I'll come over here first. I created a custom device handler for all of this to do that. So that's what's in my account there. I just called it, the type, I just called it access control lock. I named it deck door lock, because that's where this one's gonna go. And the name of the device handler is called Pi door. So coming over here to SmartThings, first things first. Remember I unlocked it with the keypad before, so here you go. There's a couple. Deck door lock was unlocked by test via keypad, so it gives you the name and who unlocked it via the keypad. All those kind of good things. I can go in here. This is the old version of the app. It does work with the new one, but the new app will not work on my big tablet. It just says it's not supported, so I'm using the old one here. So you can refresh, do those kind of things. You can unlock, lock it back up. All that works good. I'll go over here. It shows you history. Deck door is locked, deck door is locking, all that kind of stuff. Down here you see locked via keypad by test, all that good stuff. And then I am using Arboy apps for my lock management. So what happens is the Arboy app lock manager can send my device handler the add code, delete code, those kind of things, get code, and that all goes to the HTTP server running on that Pi, and then it stores the codes in flash memory in the flash file system on that device. So if it reboots, all that kind of good stuff, the codes should still be there. And then last but not least, when I hook it up, I'm going to use that battery right there. So I wanted the fail mode of the system to be unsecure, so fail unsecure. So if power is lost, that device is unlocked, which is ideal in case of emergency, but if there is a power outage, you really don't want your door unlocked. So that's what the battery's for. So I have that'll be hooked up to my Raspberry Pi and all this stuff running that. And I have a battery miner to keep that charged. So the next step after this, I think I have it all ready, will be to, of course, put that in a smaller form factor and then start tearing into my house to get wires run for all this stuff. So that's it for now.